Good morning, students. Myself, Vijay Shankar from BC Department, Chevrolet Engineering College. Today, we are going to discuss about the types of sampling. Okay. In this unit, we already completed the what is sampling and what is how we can construct the signal by using the instantaneous sampling or the ideal sampler. That is also one of the type of the sampling, and the proof of the sampling theorem and the reconstruction of the signal. Okay, under sampling, over sampling, and the equal, the Fs is equal to 2Fm. Now, another two types of the samplings other than the instantaneous sampling. Instantaneous sampling is one of the type of the sampling, and another sampling is a flat top sampling and the natural sampling. Okay. The first of all, you can see the first type is the impulse sampling, nothing but instantaneous sampling. The impulse sampling, the input signal x of t is given to the function switch here. Fs is equal to 1 by Ts. To get the response is x of n into Ts. Okay. The x of Ts is multiplied with the delta of t signal. Nothing but the impulse train. This is the impulse train. Impulse train is the signal x of t is multiplied the two functions. What is the impulse function? Means the sum of n is equal to minus infinite to infinite delta of t minus n into Ts. T minus n into Ts. What is the x of n into t is the multiplication of the two signals. Means after the sampling is x of t into the sum of n is equal to minus infinite to infinite delta of t minus n into Ts. Where here the t is also the n into Ts. Sum of n is equal to minus infinite to infinite. It can also write as n into Ts delta of t minus n into Ts. Okay. X delta of t or x S of the sampling time domain sampling equation. We already know this one. By using the impulse train, we sample the signal x of t to get the equation, mathematical expression x delta of t is equal to sum of n is equal to minus infinite to infinite x of n into Ts delta of t minus n into Ts. Okay. The switch is closed for a short interval of time tau, during which the signal is available at the output. If the input is x of t, the output is x of n into t, where n is a 0 plus or minus 1 plus or minus 2 and so on. X of nt is called the sample frequency of sample sequence, not the frequency, my students, sorry. Sample sequence of x of t. The x of t is a sample with the delta function to get the x of n into t. Where t is a time interval between the successive samples and the frequency Fs is equal to 1 by Ts or 1 by t. So x delta of t is x of t and x delta Ts of t. X delta of t is x of n into Ts, delta t minus n into Ts. Applying the Fourier transformation on both sides, it becomes of x delta of t is equal to the x of n into t, the Fourier transformation of the delta function, the shifted version. So by using the time shift property, x of t minus t naught, the Fourier transformation is e power minus j omega into whatever the samples were shifted. It is multiplied with the exponential value e power minus j omega t naught into x of omega. Okay. So here the delta function is shifted with the samples of n into t. Okay, the Fourier transformation of delta t minus n into t is e power minus j omega. Here the t naught, instead of t naught, there is a n into t. And x of omega. What is x of omega? Delta of t. It's Fourier transformation. Okay. What is the delta of t Fourier transformation? Is 1. Okay. So the Fourier transformation of this delta function is e power minus j omega n into t into 1. Actually, got it, my students? So, but delta of t is the sum of delta ts of t is a function. Delta ts of t is equal to the sum of n is equal to minus infinity delta t minus n into ts. So there is a summation is also there. So you'll get 1 by ts into 1 by ts into sum of n is equal to minus infinity. The function e power j n omega naught t. Got it, my students? See, the x delta of t is equal to x of t, the 1 by to the sum of m is equal to minus infinity. The function e power j m omega naught t. And its Fourier transformation is becomes finally by using the trigonometric Fourier series, we find out the x of f or x delta x of f is equal to the sampled version. 1 by t means nothing but the fs. Sum of n is equal to minus infinity x of f minus n into fs. Got it, my students? Minus n into fs. So you can take the signal is in between of minus fm to the fm. And the fs is equal to 2 fm. You get the periodic function. There's a periodic function at the fs and the minus fs and the 0 and so on. So like that we can get the impulse response or the instantaneous sampling. The first one. The second one is the second sampling is nothing but the natural sampling, Chopper sampling. Natural sampling or the Chopper sampling. Why it is a Chopper? Okay, the signal after the multiplying with the signal g of t. Let us take this as a g of t. Okay. After combining these two functions, previously the instantaneous sampling having only there is no any width here, only at t is equal to 0 and t is equal to 1, nothing but now the t is equal to 1 and ts, 2ts and minus ts and so on. Is the sum of n is equal to minus infinity. The delta of t minus n into ts is sampled signal with the x of t. Now here, the natural sampling, in natural sampling, the pulse has a finite width. The previously there is no any width of the sample, a finite width here. See, there is a width of the signal. For every periodic signal, there is a repeated with the tau, having the width of the tau. It is also called as Chopper sampling. Okay, in the instantaneous sampling, the same x of t signal is sampled with the impulse signal. Okay, here there is no any width. But in this natural sampling, the pulse having a finite width of tau, it is also called as a Chopper sampling, because the waveform of a sampled signal, appears to be chopped off from the original signal waveform. See, chopping means it cuts. Simply, there is a tau width. The signal is just like a chop the signal. Previously, there is no any width of that signal having their impulse signal. But in this, there is a width we'll get after the sampled version of the natural sampling. According to that, the amplitude is also changes. Got it, my students? And it localizes the signal is choked. Okay. Original signal is a continuous time signal, and after the sampled with the pulse width of the tau, the choker sampling, and the sample appears to be choked off from the original signal waveform. Let x of t be the analog continuous time signal that has to be sampled at a rate of fs, the sampling frequency. The sampled signal x of t is obtained by multiplication of sampling function and the signal x of t. Is x of t is equal to s of t is equal to x of t into x of t into the, let us take the g of t. The s of t is equal to, whenever the switch is on, whatever the signal x of t is getting at the s of t. When the switch is off, means when the c of t is equal to high, let us take this as c of t or the g of t, whatever it is. So here they wrote the c of t. Let us take the x of t into c of t is equal to s of t. When, and this signal, whenever you get the 1, the switch is on, whatever the output in the s of t getting the same signal x of t, and it holds here. And after that, 0 will get, when the 0 is get means switch is off, and there is a gap here. Then after, whenever it is a 1, again the switch is on, whatever the signal that is in the x of t, you will get at the s of t. Okay. When the c of t goes high, a switch s is closed. So s of t is equal to x of t. S of t is equal to x of t when c of t is equal to a. So here the amplitude is a, whatever the amplitude we have, with the width of the tau, pulse width, and s of t is equal to 0, and c of t is equal to 0. So when the c is a 1, we'll get whatever the amplitude we have here, a. Okay. And c of t is a 0, the s of t is also goes to the 0. Then again it is a 1, goes to the 0, and again the 1, and goes to the 0, and again it is a 1, and goes to the 0. Okay. So s of t is equal to c of t into x of t. S of t is equal to c into x of t. From the exponential Fourier series for a periodic waveform is given by periodic waveform. Exponential Fourier series is a signal is analysis equation, the synthesis equation we have. The synthesis equation x of t is equal to sum of n is equal to minus infinite to infinite x of n e power j n omega naught t. If suppose the analysis equation is x of k is equal to 1 by t, the integral of t, x of t e power minus j k omega naught t dt. This is analysis equation, and synthesis equation x of t is equal to the sum of k equal to minus infinite to infinite, k equal to minus infinite to infinite, x of k into e power, here the negative exponential, now here the positive exponential, jk omega naught t. Now here I will be taking that is as a k is a variable, changes as n. Sum of n is equal to minus infinite to infinite, x of n e power j n omega naught t. This is here. X of t is equal to sum of n is equal to minus infinite to infinite, x of n e power j n omega naught t. What is the omega naught is equal to the angular frequency, the 2 pi f naught, or otherwise it is a 2 pi f naught is a 1 by t naught. Substitute that angular frequency here. X of t is equal to sum of n equal to minus infinite to infinite, x of n e power n 2 pi the small t by the capital T. For a periodic pulse train, the C of t, the Ts is equal to 1 by Fs. Or the T naught, whatever we are taking here, the period is a sampled version. The T naught is equal to Ts, that is equal to 1 by Fs. So omega is the frequency of the C of. Got it, my dear students? Now equation 2 will becomes with x of t is equal to C of t. So C of t is equal to the x of t is equal to C of t. The C of t is equal to sum of n is equal to minus infinite to infinite Cn e power j n t 1 by t naught becomes. See, my dear students. See here, when C of t into x of t is equal to sum of n equal to minus infinite to infinite x of n, 1 by t naught is replaced as 1 by Fs, or it is a Fs, or 1 by Ts is there. Okay. Now that becomes C of t is equal to the sum of n is equal to minus infinite to infinite Cn. Instead of xn, I am writing the Cn. Instead of x of t, I wrote here the C of t e power j 2 pi n t 1 by Ts is a Fs. As a rectangular pulse train, the rectangular pulse train, the Cn is equal to Ta by T naught into sinc function, sinc Fn of t. Got it, my dear students? And this equation, the Cn is equal to, you can substitute here, or let us take is the x of t only. How we got the Cn of t is equal to Cn of t is equal to t into a by the t naught into sinc f n into t, where the t is a pulse width, the t is a pulse width of the function. Okay, my dear students. So you'll get from this equation the x of t is equal to, as the x of t is equal to the a suffix k, or a of k is equal to, and from the trigonometric function, if I use a k is equal to 1 by Ts into integral minus t by the t by 2. If I am taking the minus t by the t by 2, its amplitude is, what is the amplitude? The pulse width is a tau, and its amplitude is a k. If I am taking that a as the x of t signal e power minus j k omega naught t dt is the analysis equation. Okay, what is the a of ak means? Nothing but x of k, my dear students. X of k is equal to 1 by t, the integral t. What is that integral t? That is a minus t by to the t by 2. From minus t by to the t by 2. So 1 by t is a into e power minus j k omega naught t dt. A is an amplitude here, and tau is a pulse width. So that is equal to, you can simplify this equation, e by t is integral minus t by to the t by 2 e power minus j k omega naught t into dt is there. Now substitute here, not the substitute, expand the integral e power minus j k omega naught t by minus j k omega naught t minus t by plus t by to the t plus minus t by 2 t bar to the minus t by 2. Substitute the equations here. A by the ts whole multiplied with the t is with the t by 2 e power minus j k omega naught t as now the t by 2 minus e power minus j, whenever you can substitute the minus means here the plus j k omega naught t by 2 whole divided by minus j k omega naught t. There is many t, my dear students, here. We're applying with respect to the t only. J k omega naught simply. Now here the minus and here the minus, swap these two. A by ts, a by ts into e power minus, not the minus, is a plus first of all, is a plus jk omega naught, we can write as omega naught is equal to 2 pi f naught, that is equal to 2 pi by 1 by t naught, the t naught is equal to ts, the 2 pi f by the ts, my dear students. Okay, so 2 pi, there is no f, sorry, 2 pi by the ts into t by 2 minus, now I am after swapping these two functions, by multiplying them minus here, plus exponential we will get in the first one, and the second one is a negative exponential. E power minus jk omega naught is a 2 pi by ts into t by 2 whole divided by minus j is all, the minus becomes a plus here, jk. Now here also you can substitute the omega naught is a 2 pi by ts. Got it, my dear students? From the analysis equation, we take that as x of t, the given function is a given function with amplitude is a and with the duration of minus t by to the t by 2. Simplify this expression as we consider as x of k is a of k. So cancel the function of the t and t here. Here also the 2 and 2. Now you can write the simplified equation. And here there is a ts is there. And in the denominator also the ts is there. Get cancelled. Now the a by k, a by 2 pi 2j k into pi whole multiplied with e power j k pi into t by ts, capital T by ts minus e power minus j k pi capital T by the ts. What it matters. Now it is in the form of e power j omega jx minus e power minus jx by 2j. Here the 2j is there. You can write this 2j here. You can write the 2j here in the denominator. Then it becomes a by k pi into the total function becomes a sine x. What is the x here? The sine k pi into t by s. Okay, T by S. That is equal to, now it is in the form of sine K pi T by Ts is there. Here also you can multiply the T by Ts in the denominator and the numerator. In the numerator, we will get the T by Ts here. And in the denominator also multiply the T by Ts. Then it becomes of A capital T by the capital T with the suffix S sine pi K into capital T by the Ts whole divided by, here also the K pi capital T by Ts pi K capital T by the Ts. We know, my dear students, sine pi theta by pi theta is nothing but sinc theta, sinc function, sinc theta. Now it is also in the form of the same thing. So A T capital T by the Ts is total function sine pi t beta by pi theta. What is the theta here? The K T by Ts. So sinc T, K is also there, K capital T by the Ts. Got it, my dear students? The same function here. Okay. We got the A capital T by the Ts. See here, A capital T by the T naught. What is the T naught here? The Ts on. We already substitute the T naught is equal to, here the 1 by T naught is replaced as a 1 by Ts. T into A capital A by the Ts, sinc the function Fn into 1 by T. Fn into 1 by, or Fn into T. What is the Fn here? Fn is a N into Fs. N into Fs means here I take that is a K. Instead of K, here the N. Fs is nothing but that is equal to N into Fs means K into 1 by Ts. And already the T is there, Fn into T. So K T by Ts. Got it, my dear students? By using this analysis equation, we got a Cn is equal to, if this is a Ck means Ta by Ts sinc Fn into T. That T is a pulse width and Fn is a N into Fs. Or we got that as A suffix K is equal to T A by the Ts sinc means SINC, sinc K T by Ts. So here the K is replaced as a N. An is equal to At by the Ts sinc K has now the N, Nt by Ts. Okay, what is a 1 by Ts? Nothing but the T naught only, or Fs. So N into Ts is N into Fs is the Fn value. Now substituting this equation 4 in the equation 3, whatever we got the Cn here, substituting this equation, that is a C of t is equal to, the sum of n is equal to minus infinite to infinite. What is the Cn? We got A T by the T naught or the Ts. Here they are assuming the Ts here. Sinc Fn into T. The T is a pulse width tau only. N into Ts, N by Ts, nothing but N by Ts is equal to, here I am representing that is a N into Fs, that is equal to Fn. Okay. N by Ts replace the Fn, and the T, that T is a pulse width tau. Write it as a pulse width tau. This total function is a Cn and is multiplied with e power j n t fs. That is the equation we have in the synthesis equation. E power j k. K is replaced now the n here. J k omega naught into t. What is omega naught? 2 pi f. 2 pi f is the fs into t. We got the C of t is equal to. Substitute in this equation in 5 we have equation 1 in the 5. Okay, what is the equation 1? We got replacing the x of t is equal to the totally the s of t is equal to C of t into multiplying factor, the C of t into x of t. So what is the C of t? The total function what we have, that is a, the t is now the tau, we are changing a tau by the ts into sinc function, the sinc fn of tau into e power j n 2 pi fs into t into x of t. Okay, this total the x of t is equal to s of t is equal to. Got it, my students? Okay, see how we got this. See in this expression, s of t is equal to x of t. Whenever the switch is on, whatever the signal that is passes to the output, the input x of t, when the C of t is equal to 1. When the C of t is equal to 0, there is a gap is there, the hold, and then again it is a sample, and so on. So S of t is equal to C of t into x of t. So totally multiply the two functions. The x of t, the continuous time function, and natural sampling with having the width is there, the pulse width. It is also called as a chopper sampling. After combining these two functions, the C of t and x of t, you get the S of t. Okay. That the time domain function, the S of t is equal to a tau ts sine fn tau the e power j n 2 pi fs into tx of t. Now, what is the frequency domain of this function? Then we can apply the Fourier transformation of this. We'll get the S of t, apply the Fourier transformation. Its Fourier transformation is S of f. Here all the terms is the tau only. These two, the last two terms, not the terms here, the last two multiplication factors here, having only the t is there. Okay, therefore the S of f is equal to a tau by the ts sinc fn of tau. Now these two functions, observe here the Fourier transformation of these two. What is the Fourier transformation of x of t, the e power j n 2 pi fs into t means the frequency is shifted. The frequency is shifted with this number of samples, the n into omega s, or the fs values, n into fs. Okay, my dear students, it is the frequency. By using the frequency shift property, the x of t is multiplied with the positive exponential e power. Let us see here. The frequency shift property, the e power j omega naught t x of t. Its a Fourier transformation is x of omega minus omega. Here the omega naught is a samples is shifted. The same thing, the total function n into omega s. Shortcut notation is n into fs on. So x of f minus n into fs. The frequency domain of the signal x of t. In this natural sampling, there is some limitations in the instantaneous sampling. That limitations is in ideal sampling, the pulse width is a 0. and due to the energy is infinite, there is a noise interference is very high. Noise interference, the limitations in instantaneous or the ideal sampling means it's a previous sample, the first sampling type. In this, the pulse width is the 0, but in this the pulse width is a tau. Okay, it is not the 0. Pulse width is a 0 here in the impulse train, and in this also there is a noise interference is high. Noise interference is very high. To overcome these limitations, we need to go for natural sampling. Okay, my dear students, we need to go for the natural sampling, having pulse width. Having the pulse width, it is not the 0, and there is some energy is a finite. There is no any noise interference which occurs in the natural sampling. Okay. So in this here there is a multiplication of in the natural sampling there is a multiplication plus shaping. What is the multiplication here? The x of t is multiplied with the c of t signal, having the pulse width of the tau and the amplitude of a, and the output signal is chirped. Okay. So here, so finally we got the x of f is equal to t into a, not the t, tau a by ts, the sum of n is equal to minus infinity to infinity, sinc fn of tau, the x of f minus fs into n by using the frequency shift property. So the pulse is not the pulse, the signal is band limited to from minus omega to the omega due to the sinc function. By using the natural sampling, the sample is look like here. The center one is having the same amplitude. Going on, its amplitude is decreases with fs and 2fs. Similarly, here also, its amplitude is decreases going on when fs and 0, and here we will get the fs, here the minus fs, minus 2fs, and the 2fs here. After the sampling, the spectrum of the natural sample, by using this mathematical equation in the sinc function, whenever you can join all the amplitudes, it decreases like this. Okay, goes on, it is a decreases its amplitude. Got it, my students? It is a practically possible condition. Ideal sampling, what we discussed in the previous, the type of the sampling, the instantaneous sampling, practically it is not possible. It's a very good, but practically it is not good function. We are going to overcome the pulse width is a 0 there, and the noise interference is very high. To overcome, we need to move the natural sampling. Okay.